Hello all. Welcome to today's matchmaking webinar for the ARPA-H Breathe program, which stands for Building Resilient Environments for Air and Total Health. My name is Christopher Smith, and I am a systems engineering and technical advisor contractor to ARPA-H. The purpose of today's webinar is to provide organizations and entities with an opportunity to exchange information about their areas of expertise and their teaming needs for the Breathe program. So let's dive in. The agenda for today is that we will be giving a brief introduction, which will be given by Dr. Jessica Green, the program manager for Breathe. We will then transition to the lightning talks. And then finally, we'll close with the key next steps. With that, I will turn the webinar over to Jessica for an introduction to ARPA-H and Breathe.
Hi, I'm Jess Green, and we're sitting here today, our team on this webinar at ARPA-H. The mission of ARPA-H is to accelerate better health outcomes for everyone. And we're really excited about the Breathe program. The vision of the program is a future with healthy indoor air for everyone. The program has 3 technical areas, which are detailed on the Breathe program website. In brief, the first technical area is developing autonomous sensors for indoor air quality, with an emphasis on the innovation being around detecting bioaerosols, viruses, bacteria, molds, and allergens. And we're encouraging performers to utilize off-the-shelf sensors to also measure particulate matter and air chemistry. The second technical area is around risk assessment. So utilizing this data and other sources of data related to indoor environmental quality to then assess the risk of being in the built environment. And the third is the application of building systems to intervene in the indoor environment when and where needed. So that's the third technical area. And a part of this program entails bringing these teams together and innovating and also installing these new systems into buildings across the country for a real-world efficacy trial. Key dates are these matchmaking webinars. So today is the first one, and there'll be another one on May 29th. The solution summaries for the program are due on June 21st, and the full proposals are due August 26th. So without further ado, what we're excited to hear from is our folks that have signed up for these lightning talks. So I'll turn it over to Chris.
Thank you, Jessica. We will now begin the lightning talks. If you are a presenter, please unmute your microphone when we call your name. We will share your single slide submission on the webinar and invite you to provide a 3-minute presentation. We will verbally let you know when 1 minute remains. So without further ado, I would like to first introduce Ari Leor from Spectralogic.
Hi, everyone. What we do is developed a platform that collects air through multiple sieves and specific flow design that allows separation, mechanical separation between droplets and microbiology. And eventually we measure their signature and the mixture of signature through Raman spectroscopy, which we have a patent on doing it on a micro level. It's an ongoing process, and we have several levels of sophistication, from household measurement, which we developed for a commercial company in Israel, up to public areas where, of course, it's more important and larger system, basically. All the systems have a very small footprint. So that's basically the core technology. We focus on the aerosol and the droplets that are collected through our pumping configuration. Specific signatures are generated by Raman spectroscopy. Basically, we build a library for viruses of interest, fungi of interest, and the bacteria of interest. I mean, those that are more pathogenic than others. That's it.
Thank you very much. Next up, we would like to invite Kevin Go from Matchmaking to give his talk.
Thank you. Hey everyone, my name is Kevin. I'm a CEO of Matchmaking. Matchmaking is a nanofiber startup located in urban California. Today, I'm excited to introduce to you our innovative nanofiber technology for developing a PFAS-free antimicrobial HEPA HVAC filters, which will address TA3 within the BREATHE program. So currently, one of the significant challenges we're facing in improving air quality in commercial and residential building is the most HVAC systems are not designed to accommodate high performance filters like the traditional HEPA due to their high pressure drop. So there's a paradigm between the protection performance and the pressure drop. Higher protection also give you a higher pressure drop. That's why the currently most building HVAC system are only still using the MERV-8 filters, which has significant limitation of removing airborne pathogens and allergens. At Matrigenics, we have been developing nanofiber technology in air filtration sector for over 4 years, aiming to shift this current filter paradigm. Our nanofiber empowered HEPA filter has a significant low pressure drop. You can see from this table, it actually able to currently reduce the pressure drop by 75% compared with the commercially available Lido HEPA filter. And in this case, it actually enable them to have a potential to be using the standard HVAC system without replacing the air blowers. In addition, due to the high surface area of nanofiber, we're also able to integrate like some antimicrobial agent to our filter matrices, enable to the filters eliminate those pathogens right on the spot. By using this like
1 minute left.
HEPA filters, building owners can enhance air quality by simply replace the HVAC filters in the existing HVAC systems. And moreover, we're also able to establish the rigorous metrics to measure the success of a solution. We have a robust network of partners in HVAC industry, military, and healthcare sectors, enabling us to implement our HEPA filters across a wide range of facilities, potentially collecting the health and well-being data. So in summary, we are looking for team up with a company who is targeting TA1 and a TA2 to integrate our solution and maximize the effectiveness of our air quality interventions. Thank you.
Thank you very much. Next up, we have David Larry from the University of Texas at Dallas.
Thank you. Do you hear me okay? Yes, great. Well, I appreciate this opportunity. So over the last 10 years or so, we've been holistically bringing together measurements on multiple temporal and spatial scales of various aspects of outdoor air quality, indoor air quality, and then also our body's autonomic response. So just like the unenviable canary down a coal mine was used as a, we have found that we can actually decode our body's autonomic response to very accurately give concentrations of gases, reproduce the size distribution of airborne aerosols. And when we bring together these different facets, we can also explore several other areas. So many times, measurements of aerosols are made maybe alone, gases alone, and then we can't measure everything. So what we've pioneered actually over the last 20 years is something called data assimilation, chemical data assimilation, where we simultaneously ingest multivariate observations of different gases with a kinetic model to infer the composition of things we can't measure, say they're below the detection limit. For example, OH radicals, which are central in deactivating bioaerosols and odors and various pollutants. So we holistically bring these together, and we have already, in fact, a demonstration building in partnership with the city and the university, where we've deployed sensors across the building, outside the building. We have wearables and also a pathogen defense system, which was developed for the space station, which rapidly deactivates a whole range of
minute.
viruses. Okay, I can stop there. Thank you.
Great, thank you very much. Next up, we have Stephanie Taylor from B4 Health.
Hey, everyone. I'm really happy to be here. Thank you. So I'm Stephanie. I'm a physician of Harvard Med School. Been a physician for 1,000,000 years. Somewhere along the line, I realized how powerful indoor air quality is for human health. So I went back, got my master's in architecture and designed hospitals for over a decade. So now what I have here is our company has created a health-based indoor air quality standard. So by monitoring the metrics you see listed on the left, we have a patented algorithm which determines the health impact of both individual and combined indoor contaminants or indoor thermometrics on human physiology. You can see we look at effective indoor air quality on your immunity, on your cognitive functioning, all the things you see written there. And then we distill that into a single score if somebody doesn't have a whole lot of time to dig into the data. Our platform also has the capability to zone out and or in, however you use that word, to see the individual metrics. So we monitor indoors and outdoors, and from that holistic evaluation and our health-based algorithm, we recommend the most efficient and energy conserving remediation step if indoor air quality score is suboptimal. So we have much of the sensors in TA1. We don't have a metagenomic analysis at any DNA, RNA metabolite level. So we would definitely need that. We have TA2 covered with this health, with the risk analysis minus the bioaerosol component that could be brought into our platform. And we have the remediation recommendations, but we don't have right now the capability of actually automating with the building management system. So that's what we have. It's unique in that it's very physiologically based.
1 minute left.
But thank you. But we don't have the bioaerosol or the biosensor, and we don't have the remediation interface figured out yet. So thanks.
Thank you very much. Next up, we have Jennifer Wagner from Onsite LLC.
Hello. Good morning or afternoon, whatever part of the country you happen to be in. I'm going to give you a little bit of insight on who we are, what we do, and where we fit into the ARPA-H Breathe program. So Onsite LLC is a multidisciplinary team of scientists, engineers, and clinicians. And we have novel tools to measure and monitor environments holistically to detect, quantify, and mitigate the risk of microbiological contamination, specifically in indoor environments. The environmental parameters that we measure feed a patent-pending algorithm that's based on hundreds of thousands of data points collected in nearly 200 research experiments. This algorithm feeds the basis for automation, reporting, and dashboarding, and includes augmented and/or artificial intelligence components. This risk predicting solution is deployed in over 100 indoor spaces as we speak today. And the information obtained from deployment of our solution is used to inform effective mitigation strategies for our clients. We see our solution in technical area 2, integrating data from one or more TA1 novel sensors into existing or modified algorithms that subsequently will inform TA3 mitigation strategies for optimization of preventative measures. And I'll stop there.
Thank you very much. Next up, we have C.Y. Wu from University of Miami.
Hi, everyone. Great to meet everyone here. I'm C.Y. Wu from Center for Aerosol Science and Technology at University of Miami. So we have formed a comprehensive team consisting of academic institutions, industrial partners, and deployment entities for TA1. We have also partnered with Purdue and the KMC Control for TA3. For this ARPA-H funding opportunity, we have 2 complementary technology for bioaerosol biothreat sensing. The first one is the BioSpot virus sampler to collect and concentrate biological particles, as shown on the left-hand side of the slide. Sampling and the concentration is very important because the barrel aerosol concentration is typically low in the ambient air. And this sampler was inspired by the inhalation process in the human respiratory system as shown in the center of the slide. And this system has been successfully used in April 2020 to collect the first viable SARS-CoV-2 virus aerosol. In other studies, we have also used it to successfully collect other respiratory viruses, such as H1N1, RSV, and also OC43 when other samplers failed. This was developed by the NIAID grant and is now available through our industrial partner, Hendix. Once collected, the samples are then transferred to through an adapter to our on-the-spot detection as shown at the bottom of the slide, where preloaded reagents are discharged one by one. And the limit of detection, as you can see, is excellent. It's only 0.06 TCID 50 for H1N1, and for SARS-CoV-2 is only 2 genome equivalent. And there are no interferences of the analysis when both viruses coexist. So we offer an integrated system for sampling and a multiplex detection on the spot in one single unit with high fidelity. And complemented to this one, we also offer a portable one shown on the upper right corner, which is based on multi-angle, multi-wavelength system. And this is very compact, 7 by 7 by 4 centimeter. And this captures the optical signatures of bioaerosol particles, especially for bacteria and fungi. And the signatures are unraveled by machine learning algorithm incorporating carbon dioxide PM 2.5 and environmental parameters. And before we deploy it for field testing, this system will also be calibrated against our high fidelity system. So together with our TA3 partners, we look forward to this exciting opportunity to team up with TA2 experts for this big impact opportunity. Thank you very much.
Thank you. Next up, we have Yanhui Liu from Onsite Gene.
Hello. Hi, everyone. Hi. Onsite Gene has been a member of NIH REDX program. Our innovative instrument can complete 40 PCR thermal cycles in just 5 minutes. Let me introduce our latest development of the PicoV instrument. It is a cartridge-based sample-to-answer real-time PCR instrument. PicoV features a limit of detection of 800 copies per mil, supports up to 64 multiplexing targets, and offers a turnaround time of just 20 minutes. For the BREEZE project, we proposed the PicoV Air, which integrates PicoV with an air sampler, a cartridge magazine, and a cartridge transfer arm for autonomous pathogen monitoring. In the slide, you will see features in red, which we already have achieved. The features in black, which are in design phase. Testing for 25 pathogens has a turnaround time of 45 minutes, 25 minutes for air sampling, 12 minutes for RNA-DNA purification, and 8 minutes for 40-cycle real-time PCR. If we run air sampling parallel to the PCR test, the turnaround time dropped to just 25 minutes. Our cartridge at the heart of our operation, they come pre-packed with reagents for NA extraction using magnetic beads. The PCR master mix is in dried form with a shelf life of 6 months, and this cartridge can be shaped and stored at room temperature. Using our patented technology to move and mix liquids, each cartridge contains 16 PCR tubes, each with 4 fluorescent channels, allowing the detection of 64 pathogen targets.
1 minute left.
We can increase the detection to over 100 targets by adding more PCR tubes and increasing to 6 fluorescent channels. Third-party Techman assay can be used on our cartridge with automated modification. Our nested PCR on the cartridge can enhance LOD by 10 times when needed. To reduce operation cost, we propose using two types of cartridges, screening and identification. The identification cartridge is used only when indicator pathogen is detected. For high volume testing, this can lower cost to like $2 per screening cartridge and $7 per identification cartridge. We are eager to support the project and collaborate with other Tier 1 teams to provide the best solution. And also we are looking for, T3 to lead the project. For more information, please visit our website at onsitegen.com. Thank you for your attention.
Thank you very much. Next up, we have Nita Madhav from Ginkgo Bioworks.
Hello, everybody. I'm Nita Madhav. I head the Epidemiology and Modeling Group at Ginkgo Biosecurity, which is the Biosecurity and Public Health division of Ginkgo Bioworks. So today I'll talk about two areas where Ginkgo brings strong experience and deep expertise that would be of relevance to the ARPA-H Breathe program. And the first area is in performing continuous pathogen monitoring and testing at scale. So we've collected over 14 million samples to date, spanning several program types. During the COVID pandemic, for example, we partnered with over 4,250 K-12 schools in 38 states to perform voluntary nasal swabbing, which allowed schools to stay open and take mitigation measures when indicated by test results. We've also, over the past 2 years now, partnered with US and international governments to perform aircraft and airport monitoring for pathogens. So our flagship program is with the US CDC. It's the Traveler-Based Pathogen Genomic Surveillance Program. And in this continuous monitoring program, which operates at 9 airports across the US, it includes multiple testing modalities, such as voluntary passenger nasal swabs, as well as aircraft and triturator wastewater collection. And in this program, we are also piloting pathogen air monitoring, where we've collected over 300 samples to date. In these programs, we perform both PCR tests as well as genomic sequencing, and our team works from wet lab to dry lab, ranging from assay development to bioinformatic analysis. So through this work, we've demonstrated the ability to test at scale in numerous challenging environments, and this is a critical component to deploying devices and demonstrating the effectiveness of mitigation measures to improve the health of building occupants. Our team's second broad area of expertise is in risk analytics. We contextualize programmatic insights with data from our open source intelligence and horizon scanning platform, which provides a global picture of circulating pathogens. Additionally, we perform algorithmic threat assessments on over 150 pathogens and apply epidemiological analyses and modeling to assess real-world and potential health outcomes. Our computational models incorporate person spread dynamics, as well as mobility patterns and mitigation measures. Much of our work to date has looked at global patterns, and a couple of our more recent publications that have been in the peer-reviewed literature are shown here. We're able to apply these mechanistic approaches to smaller scales, including the community and building levels. Our epidemiology and modeling team also routinely provides support for pathogen monitoring programs, including program design, sampling strategy, baseline determination, and time series analyses on pathogen detection data. So in conclusion, Ginkgo Biosecurity brings strong expertise that would be fantastic for the ARPA-H Breathe program, particularly in TA2. So if you're interested in further conversations, please don't hesitate to reach out.
Thank you very much. Next up, we have Chris Davis from Resonance.
My name is Chris Davis. I'm with Resonance. The company's origin was to develop software as a medical device diagnostic products to diagnose COVID, TB, RSV, and flu from a forced cough vocalization. And what I'm going to talk to you about today is a personal wellness and workforce health product called FCV Sentinel. And if you think about it, the goal of the ARPA-H program is to keep the spread of infection between the building's most valuable assets. That's the people, right? The problem is that people are only working in this pristine environment that we envision for, let's say, 40, 50, 60 hours a week, and they're outside the building for another 100 to 120 hours a week. So how do you know that they're not coming to the building sick? And so that's where we come in. What we do is we have a mobile app. Our solution is totally digital. Processing is done in the cloud. Each individual that works in the building builds a baseline of what their healthy respiratory system is. And then before they come to work, they submit a set of cough samples and they determine whether or not they match that healthy baseline or not. So really what we have here is an early warning of a pre-symptomatic human spreader coming into the building before they know they're actually sick and spreading, pathogenic bioaerosols. Our software is sensitive enough that we can pick up respiratory changes caused by viruses, pathogens, molds, particulate matter, anything. It's non-invasive. The results are about 2 minutes or less in terms of having where's my score? How do I compare to my baseline? And all of this data can be pushed to web-based and customized dashboards. So we would consider ourselves sort of a human biosensor, a TA1-H, shall we say. And the nice thing is that forced cough vocalizations, these are intentional coughs, are a very rich source of biomarkers and other data. Plus the application allows you to record symptoms and vital signs. So we have a rich set of human data that we can feed into TA2 for risk assessment. And then once remediation measures are taken place, we can assess by monitoring the health of the people coming in the building, did those actually work or not? Again, zero installation, all hardware, no software. It's a mobile app. More information is contained under FCB Sentinel. There's a live link there, and I have contact data at the bottom of the slide. So again, we're looking to basically integrate into TA2 and be a TA1 sensor. Thank you.
Thank you very much. Next up, we have Daryl Johnson from SWRI.
Hi, I'm Kristen Favela, and I am presenting for Daryl. Southwest Research Institute, for those of you not familiar, is a nonprofit, private, and applied R&D organization founded in 1947 and have since grown to a level of over 3,000 employees. So we have a very wide range of capabilities across many fields, including microbiology, chemistry, engineering, and computer science. So some of our core capabilities relevant to the BREATHE effort are summarized here. Under monitoring and analysis, we are concerned with what is there and how much. We have experience in challenging, treating, and detecting from a wide range of materials, and in using different application techniques. So for example, we have certified materials are completely sterile for JPL prior to spaceflight. We are very flexible in that we can utilize very strict FDA, EPA style protocols or follow procedures as designated by our clients or develop our own custom methods. We have a very wide range of capability to identify what types of biological materials are present, as well as a wide range of chemical detection capabilities, including for comprehensive air monitoring. In addition to standard run-of-the-mill type organisms, we are also highly experienced with more exotic materials, have BSL-1 to BSL-4 capabilities along with a partner organization, and this is highlighted under microbial forensics. So this work requires us to be very nimble in terms of being able to detect both known toxic materials and microbes, as well as more of your emerging threats. So moving on to EPA GLP studies, the main takeaway here is that we have a wide range of accreditations, as well as the flexibility to operate in both R&D space and regulated project space. So another one of our core strengths is facilities. We have a large amount of diverse laboratory space that allows us to operate across many scales. And so, for example, we have both the space and the resources to mock up an entire building to use for beta testing, as well as clean rooms where we could release microbes and see how the sensors perform. And finally, we have a very strong computer science resources, including programs that allow us to rapidly interpret very complex environmental data from mass spectrometry platforms and others. So not specifically highlighted on this slide, but also relevant to computer science capability is our diverse background in engineering to include small electronics, robotics, and autonomous solutions and sensors. And thank you very much for your time.
Thank you very much. Next up, we have Morteza M. from Michigan State University.
Hi, everyone. I will discuss the methodology we have been developing over the past couple of years for the isolation and purification of airborne viruses. As you know, detecting viable viruses in the air is crucial for evaluating the health risks they pose. Numerous methods have been developed to purify and detect these viruses, but many of them require extensive processing time and often face limitations such as the insufficient collection of viable viruses. To address these challenges, we have employed an efficient technique based on magnetic levitation or maglev system. This system enriches materials based on their densities using the same technology that propels the fastest electric trains. It's a simple, inexpensive, rapid, and energy-free technique that enables the separation, measurement, and analysis of a wide range of biosystems, including cancer cells and plasma proteins based on their densities. Before applying this technique to virus studies, we evaluated and validated our maglev system by levitating GFP-positive E. coli as a model microorganism. Specifically, within 30 seconds of applying the bacteria into the maglev system, they levitated and remained for 30 minutes. When then we validated them for their viability using FACS analysis. To evaluate the maglev's capacity in enriching human viruses, we used SARS-CoV-2 at various concentrations, and after their levitation, we collected different fractions from the maglev column and analyzed them using techniques such as RT-PCR, and our results showed that the highest purification of viruses was found in the top fraction. Further analysis on SARS-CoV-2 and also influenza H1N1 viruses stated that our maglev system successfully enriched viable airborne viruses from air samples. Additionally, the enriched viruses obtained through this method exhibited sufficient purity for direct use in subsequent analysis. We are now working on an automated version of the system that can collect, enrich, and analyze airborne viruses in a single process. In sum, our developed system is portable, user-friendly, and cost-efficient. It has the potential to provide proactive surveillance data for monitoring airborne infectious disease. Thank you so much for your time and attention.
Thank you very much. Next up, we have Gedi Minalis from Rutgers University.
Yes, good afternoon and good morning. So I am Gedi Minalis from Rutgers University, New Jersey. And one of the main research areas of my lab is development, testing, and validation of various novel aerosol and especially bioaerosol collectors. And one of the challenges facing bioaerosol detection, especially for rapid detection in low concentration environments, is how to deliver sufficient biomass into a detector. The challenge could be solved in two ways. We can either sample very large amounts of air or concentrate sample into small amounts of liquid. Use of liquid as a capture medium is very important because it is conducive for analysis by multiple techniques. There are many liquid-based bioaerosol samplers, but most of them use large amount of collection fluid, and that lowers detection sensitivity because only a part of the liquid is analyzed. We took a different approach. We took a hint from nature and developed a collector that is able to concentrate the entire sample into a small droplet. And that hint from nature is the following. As you know, lotus flower is always clean, and it is clean because it turns out that its surface has a nanostructure, and as a result, any dirt or particles are removed by rain droplets that are simply able to roll down their leaves and pick up the particles. So we applied the same principle and developed an electrostatic collector with a superhydrophobic collection surface, which you could see on the top right, the schematics. The incoming particles are charged and then deposited onto a narrow strip that is coated with a superhydrophobic material. And at the end of the sampling, we introduce a droplet, and due to slight angle and the gravity, the droplet rolls down and captures all the particles in it. So as a result, at the end of the sampling, you have the entire sample in a single droplet that could be as small as 5 microliters. And through microfluidics, then the droplet is delivered to the analytical part. You can see the suggested process diagram toward the bottom of your screen. Because the device is based on electrostatics and has an open channel device, it consumes very little power. There is very little pressure drop, and it enables very high sample concentration rate, which is crucial for fast detection. So this collector could serve as a front part for the detector for BREATHE project and is highly applicable for TA1. So currently we are looking for partners to integrate it with sensitive and multiplexed detection system. Thank you.
Thank you very much. Last, we have Jensen Z from Syracuse University.
Hello. Okay. I think related to the BREATHE program, and we have several capabilities that we're looking for partners to collaborate with. The first one is on the testing. We can provide testing capabilities at multiple levels. For example, at the laboratory level, which you can see on the left, we have full-scale environmental chambers, stainless steel, so you can really create a controlled environment of temperature, humidity, biocontaminant levels to test the different sensors, and also can test the air cleaning devices as well. Then second level, we can look at is the room level field testing. And then we also have the whole building test bed. And so the second area is mitigation strategies and technologies. So in the past, we have been evaluating various air purification units, technologies, and also trying to integrate that with the building systems controls. And the third one is in the modeling the transport and transformation and transmissions of biocontaminants, and these are very important as well to provide insight on developing the strategies so we can actually control the source, minimize the transport, and mitigate through air purification, ventilation, and so on. The last one is more about integrating with the building systems, which we have expertise in AI, machine learning-based model, predictive controls. And in the past, we have done several large projects that integrating sensors, IAQ sensors with the intelligent control systems, but mostly focusing the volatile organic compounds
1 minute.
and other gas components. So we are looking for sensors, the biosensors that can really detect very low level of pollutions in the real time or near real time as required by this program. I have listed the contact, myself, Jensen Zhang, and also my colleague, Bin Dong, is an expert in AI-based controls and systems integrations. For example, how to implement control systems in existing BMS. Myself has been doing the indoor air quality research for the last 30 years. So, from the source control, the air cleaning technology to systems integration as well. So I'd be happy to talk more with potential partners. Thank you.
Thank you to all our presenters, and thank you all again for joining today's webinar. As a reminder, we've recorded today's webinar and we will post the slides and recording on the BREATHE program page once those are available. Please continue to check the BREATHE website listed on this slide for the program updates, including additional FAQs and the final solicitation being posted in the next coming weeks. If you are interested in submitting a solution summary or proposal and would like to find potential teammates, you can also visit our teaming page. Solution summaries and proposals should address all 3 technical areas, so we encourage you to reach out to potential teammates if needed. This concludes the webinar, and I hope you have a great rest of your afternoon.